Now we are going to discuss the relative atomic mass. If you have seen the video on the structure of the atom, you will know that protons, neutrons, and electrons, and therefore atoms, are all incredibly small and incredibly light. For example, a proton and a neutron weigh approximately 1.7 times 10 to the minus 27 kilograms, and these are both about 2,000 times heavier than an electron. It is therefore most useful to describe the mass of an atom by comparing it to a standard atom, giving us what is known as a relative atomic mass. We can formally define a relative atomic mass, or our AR value, as the average mass of one atom of that element relative to 1/12 the mass of one atom of carbon-12. What this means is that we use one atom of carbon-12 as our standard atom, where carbon-12 is just an isotope of carbon, specifically the most commonly occurring isotope of carbon that contains 12 neutrons, and therefore has a nuclear symbol of 12,6C. This atom is chosen as a standard atom, as is very commonly occurring, and also because it allows chemists all over the world to compare the masses of atoms to one standard. As carbon-12 has a mass number of 12, we therefore know that there is a total of 12 protons and neutrons in the nucleus of an atom of this element. As we have seen, when the majority of a mass of an atom isn't in the nucleus in the form of protons or neutrons, we can therefore see that 1/12 the mass of an atom that contains 12 protons or neutrons is going to be approximately equal to the mass of a proton or a neutron, as protons and neutrons have essentially the same mass. 1/12 the mass of one atom of carbon-12 is only approximately the mass of a proton and neutron, because there will be some mass due to electrons. But in general, we can say if an element only has one isotope, its relative atomic mass will be exactly the same as its mass number. Remember that different isotopes of an element will have exactly the same number of protons but different number of neutrons. An example of an element that only has one isotope is fluorine, which has the chemical symbol of F. The mass number of fluorine is 19, and its atomic number is 9. Telling us that an atom of fluorine contains 9 protons in the nucleus and 10 neutrons, as the number of neutrons is the difference between the atomic number and the mass number. And if the element only has one isotope, then its relative mass is just a number of protons and neutrons in a nucleus of atom of that element. So for fluorine, the relative atomic mass, or the AR value, it's just going to be equal to the mass number, which we can see from the nuclear symbol is 19. What this means is if an atom of carbon-12 has a mass of 12, then an atom of fluorine has a mass of 19. So what about if an element has more than one just isotope? Well, we need to look at the definition of our relative atomic mass, which tells us that this value gives us the average of mass of one atom of the element. What this means is that if an element has more than one isotope, the relative atomic mass is going to be the weighted average of all of the isotopes. To see what we mean, let's look at an example. Chlorine is an example of an element that exists in more than one isotope. And you can see the nucleus symbols for the two different isotopes in this diagram, because both isotopes of chlorine have the same chemical symbol Cl and the same atomic number 17. However, what is different between the two isotopes is a number of neutrons and therefore the mass number. For chlorine, what we find is some 75% of all chlorine atoms are the isotope on the left-hand side, which has the mass number 35. And the remaining 25% of chlorine atoms are the isotope on the right with a mass number of 37. As a result, our relative atomic mass, which is the average mass of one atom of the element, is an exactly 35 or 37. Instead, the relative atomic mass for chlorine, or the AR value, is the weighted average of the isotopes, which in this case is 35.5.